Far beyond our solar system lies K2-18b, a mysterious world about 120 light-years away.
But K2-18b is not another Earth. It is about 2.6 times Earth's radius, and roughly 8.6 times its mass.
Before James Webb studied its atmosphere, K2-18b had already been discovered in 2015, using NASA's K2 mission. By studying starlight passing through its atmosphere, astronomers began finding clues about what this distant world is made of. James Webb can study this atmosphere by analyzing infrared starlight filtered through it, revealing the chemical fingerprints of different gases. Webb's observations revealed methane and carbon dioxide in K2-18b's atmosphere, giving scientists a much clearer chemical picture of this distant world. K2-18b orbits within its star's habitable zone, where liquid water could theoretically exist. But that alone does not prove the planet is habitable. Scientists have proposed that K2-18b could contain a water-rich ocean beneath its hydrogen-rich atmosphere, but its internal structure remains uncertain. Despite the exciting discoveries, K2-18b's atmosphere is not confirmed to be Earth-like. Scientists believe it may be rich in hydrogen. An earlier Webb analysis reported a possible DMS signal, a molecule associated with life on Earth. But that was not proof of life. But later analyses questioned how strong that signal really was. Scientists need more observations before DMS can be considered a reliable detection. Those discoveries make K2-18b fascinating, but scientists still have no confirmed evidence that life exists there. K2-18b does not orbit a sun-like star. Its host is a cooler red dwarf, giving this distant world a very different environment. When K2-18b crosses its star, some starlight passes through its atmosphere. Webb can analyze that light for chemical fingerprints. These atmospheric fingerprints revealed methane and carbon dioxide. They tell us about the planet's chemistry, but they do not prove that life exists there. Some models suggest K2-18b could contain a water-rich layer beneath a hydrogen-rich atmosphere, but its interior has not been directly observed. K2-18b lies in its star's habitable zone, but that only describes orbital conditions. It does not prove the planet can support life. Now comes the biggest question. If humans ever reached K2-18b, could an astronaut actually survive in its environment?
Based on everything scientists know today, an astronaut could not safely survive in K2-18b's environment. Its atmosphere, pressure, and surface conditions remain.
Reaching K2-18b would require propulsion and life support technology far beyond what human missions can currently achieve.
Even before survival becomes the problem, reaching K2-18b is almost unimaginable. The planet is roughly 120 light-years from Earth.
Right now, scientists have interesting atmospheric clues, but no confirmed evidence of life. K2-18b remains a world of unanswered questions. The mystery is far from solved. More observations could help scientists determine whether these atmospheric signals come from chemistry, geology, or something more. Remember, we have no clear photograph of K2-18b. Its appearance is reconstructed from telescope data, physics, and scientific models.
These gases help scientists understand the chemistry of K2-18b. But atmospheric chemistry alone cannot tell us that life is present.
During a transit, starlight passes through the planet's atmosphere. Webb analyzes that filtered light for molecular fingerprints. Methane and carbon dioxide give astronomers valuable clues about the planet's atmospheric chemistry, but they are not proof of life. Scientists use the atmospheric observations together with planetary models to investigate whether K2-18b could contain a deep water-rich layer. Even if a water-rich environment exists, water alone cannot prove life. Scientists must also understand the planet's chemistry, energy sources, and physical. Even if humans could reach K2-18b, an astronaut could not simply step outside and breathe. Its atmosphere is not known to be breathable. And there is another problem. Scientists do not yet know whether K2-18b has a solid surface where an astronaut could actually land. Because of its possible hydrogen-rich atmosphere and water-rich interior, K2-18b has been proposed as a potential Hycean world.
For life to exist, water alone would not be enough. Scientists also need to understand energy sources and chemistry capable of supporting biology.
Astronomers, including Dr. Niku Madhusudan and collaborators, have used observations from the James Webb Space Telescope to study the atmosphere of K2-18b. The challenge is separating a genuine atmospheric signal from noise or other chemistry. Scientists therefore test multiple models against the same observations. Even when a molecule is detected, scientists must determine how it formed. Chemistry can have biological, geological, or other explanations. More observations can improve the signal and help scientists distinguish real atmospheric chemistry from noise, uncertainty, or competing explanations. When you see a detailed image of K2-18b, remember, it is a scientific visualization based on observations, not a close-up photograph of the planet. K2-18b is about 120 light-years away. The light we receive today began its journey roughly a century ago. We cannot visit K2-18b, but during a transit, its atmosphere leaves measurable signatures in starlight. Webb can analyze those signatures from Earth. The strongest evidence so far concerns atmospheric chemistry. But chemistry alone is not enough to establish that life exists on K2-18b. Future observations may reveal more about its atmosphere and interior, helping scientists test whether K2-18b is truly capable of supporting life. Even if K2-18b eventually proves capable of supporting life, that would not make it safe for humans. An astronaut would still need complete life support and protection. K2-18b is much larger and more massive than Earth. Its atmosphere and possible interior may also be fundamentally different.
K2-18b has intriguing chemistry and possible water-rich conditions, but the evidence still falls short of confirming life.
K2-18b reminds us how much we can learn from worlds we may never physically visit, simply by studying the light that reaches our telescopes. The biggest mystery remains unanswered. Can K2-18b actually support life? Right now, scientists simply do not know. K2-18b may hold clues to how planets beyond our solar system evolve, but whether life exists there remains one of astronomy's biggest unanswered questions. Maybe K2-18b holds an answer. Maybe it doesn't. But every new observation brings us one step closer to understanding worlds beyond our own.